Okay, so for today, we'll discuss level curves and contour map. Consider the function defined by z equals f of xy. The level curve at z equals c is actually the set of ordered pairs xy such that f of xy is equal to c. Meaning to say, you will give specific value for z, and in this case, c, and this will be the level curve. And you can graph it or you can see it on a two-dimensional Cartesian plane. Now, if we have a function of three variables, so suppose we have w equals f of x, y, z, the level curve at w equals c is the set of ordered triples x, y, z such that f of x, y, z is equal to c. So a level curve is a curve or a surface wherein you specify a value for the function. In this case, if we have three variables, the level curve will be at w equals c. So you can look at it on a three-dimensional system. Now, on the other hand, contour map of the function f is the set of level curves or level surfaces by considering different function values. So if you will differentiate the two, level curve is the cross section of the surface. Contour map is a topographic map of the surface. So meaning to say, contour map is actually a collection of level curves or collection of level surfaces. Let's say, for example, we have this function, f of xy equals 1 over x squared plus y squared. And you want to determine the contour map of this by specifying different values for z. In this case, z equals 1/4, 1/2, 1, 2, and 4. Okay, so from this function, you will just assign different values for z. So if z is equal to 1/4, so you will be having an equation 1 over x squared plus y squared equals 1/4. By simplifying that, that will be a circle of radius 2 with center at the origin. Okay? And this will be the contour map of the function. So if z is equal to 4, so that will be a circle of radius 1/2. If z is equal to 2, that will be a circle of radius 1 over square root of 2. If z is equal to 1, that will be a unit circle. So that is a circle with radius 1 centered at the origin. If z equals 1/4, that will be a circle of radius 2 units. All of these circles have center at the origin. So this should look like your contour map. So that is just a collection of level curves. In this case, collection of circles. If you will graph the function, the entire function, over a three-dimensional system, this will be the graph of the function f. Another example, suppose we want to determine the contour map of this function, z equals g of xy equals y minus x squared. So here, again, you will specify different values for z. In this case, in our case, we use z equals 2, z equals 1, z equals 0, z equals -1, and z equals -4. So the graph of the level curves are parabolas with various vertices. If z equals 0, so that will be a parabola with vertex at the origin. Okay? If z equals 1, that is a parabola with vertex at the point 0, 1, and all of these parabolas are opening upward. All right. And notice that this will be the graph of the function on a three-dimensional system. Let's say, for example, we have this function, w equals g of x, y, z, equals x squared plus y squared minus z. And we want to determine the contour map of this function by considering the level surfaces at w equals -2, -1, 0, 1, and 2. So since this is a function of three variables, the level surfaces can be drawn on the three-dimensional system. So you will just assign these values for W. So you will have an equation now involving three variables. And notice if you vary this W, so you will have actually the graph of a paraboloid on the three-dimensional system. So for W equals 0, so that is the paraboloid opening upward, is the one that I'm telling you. The vertex of that paraboloid is at the origin. If W equals -1, so that will be the paraboloid, again, opening upward with vertex at the point 0, 0, 1. If W is equal to -2, that will be a paraboloid opening upward with vertex at 0, 0,